In this episode, we're going to look at first hop redundancy protocols. I'll show you how to do it, and we'll talk about the concepts along the way. Spanning tree protocol provides loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if a gateway router fails. First hop redundancy protocols provide redundant default gateways for end devices with no additional end-user configuration necessary. By using a FHRP, two or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. What we're going to do is we're going to configure hot standby routing protocol, which is a first hop routing protocol. Then we'll configure HSRP on routers, which serve as the default gateways for hosts on multiple LANs. When we configure HSRP, we will create a virtual gateway that uses the same default gateway address for hosts in both LANs. If one gateway router becomes unavailable, the second router will take over using that same default gateway address that was used by the first router. Because the hosts on the LANs are configured with an IP address of the virtual gateway as the default gateway, the host will regain connectivity to remote networks after HSRP activates the remaining router. We'll be discussing how to configure HSRP to provide redundant default gateway devices on hosts and LANs. After configuring HSRP, we're going to test that configuration to verify that hosts are able to use redundant default gateway if the router gateway device becomes unavailable. Then we'll discuss configuring HSRP active router, configuring a HSRP standby router, and then finally we're going to verify HSRP operation. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Hot standby router protocol configuration guide. I got the Packet Tracer lab open up here. On the left side, we have our work area. We see the topology. We can do all the configurations there. That's the main Packet Tracer window. On the right, I have the instructions. On the way bottom right, I have the actual instructions from Packet Tracer itself. This opens up when you open up the Packet Tracer file. On the upper right, the bigger area, I have the Word document of those same instructions. I got the Word document open because as we do the Packet Tracer lab, there's questions that we have to fill out, and this will allow me to enter in my answers into the questions and save that document. First thing we see is our addressing table. In our addressing table, just like in our topology, we can see we have three routers. These three routers right here, the redundancy. Then we have the internet, which has IP address that we got set up. Then we have our hot standby routing protocol virtual gateway. We're going to create a virtual gateway in here to handle these two connections. Then we have some switches. They have IP addresses on them. We have some PCs and a web server. If we look at our topology, this bottom part right here, this bottom part is a local area network. It has one network address. All these devices are on the same network. What's different about this network compared to the traditional smaller networks or home network is there's actually two default gateways, or not default gateways, but two connections to routers that leads us to other networks. There's two ways off of this network. We can't necessarily have this. What would happen here is we'd set on PCA, we'd set the default gateway to just one of these IP addresses as your default gateway. And if that connection would go down, because the operating system only handles one IP address for the default gateway, and that connection went down, that default gateway went down, that PC wouldn't be able to connect on the network. What this hot standby routing protocol allows us to do is create a virtual one. A lot of times people will have the virtual router here in the middle, but it's an IP address that is shared between these two routers, router 1 and router 3 here. And the protocol will communicate back and forth and say, okay, one of you will be active, one of you will be standby. And we route all of our traffic, our default gateways, we set as that IP address on that virtual router, on that virtual gateway. And then because of the redundancy protocol, one is active, one is in standby, and if it fails, the virtual router, instead of sending it to the active one, will now send it to the new active one because the old active one failed. Here we have some objectives. We're going to configure HSRP for the active router, standby router, and then we're going to verify that the hot standby routing protocol is operational. Instructions, part 1, we're going to verify connectivity. Go to the desktop of PCA, so I'm going to go ahead and click on PCA and open up the command prompt. From here, we're going to trace the path from PCA to the web server using the tracer command. And so I'm going to go ahead and type that in here in our command prompt on PCA. Trace RT, which is short for trace route, and then the IP address, 209.165.200.226. Hit enter, and what's happening is it's giving us the path to the web server. So it's going from PC1 here and working its way through the network. We can see that we go to our default gateway, we go to another router here, we go into the internet, which this is the address of our internet, and then finally we have our web server. And so we can see the path where PCA, we then go into router 1, into router 2, cross the internet to our web server. That's what the trace route is giving us. Question: which devices are on the path from PCA to the web server? Use the addressing tables to determine the device names. Okay, we're going to scroll up here to our addressing table, and then we're going to find these IP addresses. So the first IP address, 192.168.1.0. That would be right here. That is router 1. So our first hop is router 1. Next hop is 10.1.2. 10.1.1.2 is right here on router 2. So it goes from router 1 to router 2. If we look at our diagram, that's what's happening. PCA to router 1 to router 2. Then we go into 10.100.100.2. 10.100.100.2 is our internet. And so now our path is PCA to router 1 to router 2 to the internet. And then our last IP address is 209.165.200.226, which is the IP address of our web server, the one we are trying to contact. So our path was router 1 to router 2 to the internet, to the iNet, and then finally the web server. Path once again was R1 to R2 to the iNet, and then finally to the web server. On to step 2, trace the path to the web server from PCB. I'm going to go ahead and minimize PCA, click on PCB, open that up, open up my command prompt, and type trace RT, and then put the IP address of the web server in there, 209.165.200.226. And we're going to go through that same process again where it finds each hop. Here's our first hop, 192.168.1.3, then 10.1.2, 10.100.100.2, 209.165.200.226. Some of these look familiar from the PCA trace route we did. Actually, these last three, they're the same. Let's scroll on up to our list to find out which device has 192.168.1.3. And looking through our list, 192.168.1.3. Oh, right here is 192.168.1.3, and that's on R3. And so our trace route takes us from PCB up to R3. Then the next IP address is 10.1.1.2. And that here, once again, is the router 2 address. So our trace route now takes us from PCB to R3 to R2. Then we have 10.100.100.2. Find that IP address in our addressing table. That is our iNet. That's our internet. That is this location. So our trace route now goes from PCB to R3 to R2 to the internet. And then finally, our last IP address. The last IP address here is 209.165.200.226, the web server. Right there. And so our final route goes from PCB to R3 to R2 to the internet to the web server. Remember what the route was for PCA? From PCA to R1 to R2 to the internet to the web server. The last parts right here, they were identical because that's the single path to the internet. The only difference is PCA goes up to R1. So right there, it was sending the traffic there. And then PCB went to R3. That's this path right there. And so that was the only difference in the trace route. Let's go down there and answer our question. Answer here was, we went from R3, R2, then to our internet, and then the web server. Step 3, observe the network behavior when R3 becomes unavailable. Select the delete tool from Packet Tracer and delete the link between R3 and S3. Delete this link right here between R3 and S3. Up here in Packet Tracer, this little dark square with a triangle pointing to the left with an X in it, that's the delete tool. I'm going to go ahead and click on that. Now notice my cursor is this X. I put the center of the X over this black line, click on it, and it deletes it. Right now, I'm going to go back up here and choose the select tool once again. So next time I get in here, I have that. Otherwise, if I click on something, it'll delete it. Step 3B, open up a command prompt on PCB, execute the trace route command with the web server as the destination. Okay, go ahead, open up my PCB. The command prompt is still open. We're going to execute that trace route command. So trace RT to 209.165.200.226. Or for those of you who use Windows a lot, you could just use the up arrow key. I'm going to go ahead, hit enter. And what's happening now is it's trying to connect to the device that's going to let it get to its destination, which is the default gateway. And PCB has its default gateway set as this IP address. It cannot get there. It cannot get there. And so that's what we're seeing here in our trace route. We are timing out because we can't even get to our first hop. And so it's going to try 3 times and it's going to time out. And then it's going to try it again and then again. And finally, it's just going to error out and say, I can't get to its destination. And as you can see here, we are timing out. Compare the current output with the output from step 2. Now, step 2 here was R3 to R2 to the internet to the web server. Now on PCB, we request timed out because we can't even reach the first path. So what are your results? Well, our results are request timed out, and that's due to the path to the web server has been broken. On the step 3B. Click the connections icon in the lower left corner of the packet tracer window. Locate the copper straight through icon in the palette of the connection types. Well, what they're looking for is down here on the bottom left. We want to click on this orange lightning bolt. That's the connections icon. And then over here in this kind of the submenu area, we are looking for the copper straight through. Right here, that's the solid line on a diagonal. I'm going to go ahead and click on that. Now, if I want, and notice my icon has changed. It's changed to an end of a cable. And if you look at this, the upper left corner is like an RJ45, and then it's a piece of wire coming off, signifying this is a cable you're going to connect into a port. Step 3E, click on S3 and select the Gig 2 inner port. Click on R3 and select the Gig 00 inner port. Or sorry, the Gig 00 Ethernet port. So once again, I have the copper straight through selected. Click on S3 and select the Gig 02. That's all the way down on the bottom. They list the fast Ethernet first, and then the gig is listed on the bottom. And notice it's saying one end of my cable is plugged into S3. Now we're looking to plug it in somewhere. And the instructions say, click on R3 and select Gigabit Ethernet 00. I'm going to go ahead and click on R3. It's going to list the available ports. Here's Gigabit Ethernet 00. After the link lights on the connection are both green, test the connection by pinging the web server. The ping should be successful. Now we're waiting for the switch to go through its negotiation. It takes about 30 seconds. What I'm going to do is I'm going to click the fast forward button down here. In Packet Tracer, we have a fast forward, speeds up time. Click it once, it goes ahead 30 seconds. Now we have green lights. Let's open up PCB and try this over. Notice it failed after 15 attempts and it stopped. What I'm going to do is just up arrow, because we want to do that trace route command to the web server 209.165.200.226. Hit enter. And hopefully it should work. And there we go. We have the IP address for our default gateway, which is on R3. Then we have the IP address for an interface on R2. We have the IP address of our internet. And then finally we get the IP address of our web server. The path, the connection has been restored. Takes care of part 1. On to part 2. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Part 2, configure hot standby routing protocol active in standby routers. Step 1, we're going to configure HSRP on R1. We're going to go in here, we're going to configure HSRP. Configure HSRP on the G01 LAN interface of R1. I'm going to go ahead and click on R1. I make this window a little bit bigger just right away because it helps with the wrapping of the text and it formats a little bit better. Go ahead and log in. There's no password, so I can hit enter, then type enable, brings us into privilege exec mode. We want to work with an interface, so we need global configuration mode, so I'm going to go ahead and type config T. Now, we want Gig 01 interface. Interface Gig 0/1. Step 1B, specify the HSRP protocol version number. The most recent version is version 2. So we want to use version 2. Standby version 1 only supports IP version 4. We're not using any IP version 6 addresses at this point in time, but by using version 2, you are future proofing your installation. Eventually, you're most likely going to venture into the IP version 6, so why not set it up right away? Once again, we want the standby version to be version 2. Standby is our keyword, then version, and then what the number of that option is. We set that up. On the C, configure an IP address of the virtual gateway. The address must be configured on any hosts that require the service of the default gateway. So we're going to configure the IP address of the virtual default gateway. Then the address must be configured on any host, those would be our PCs, of that default gateway. It replaces the physical interface address of the router that has been previously configured on the host. And when we did our trace route, PCA, PCB, they already manually had the default gateway set as this interface right here. PCBs here, PCAs here. We need to go in and change it to that virtual IP address. Multiple instances of HSRP can be configured on a router. You must specify the HSRP group number to identify the virtual interface between routers in the hot standby routing protocol group. Number must be consistent between the routers in that group. Here's the command. This is that number that specifies what group it is. All routers in the group must have the same number. Okay, we are still in the configuration of our G01 interface. Now, to configure out the standby protocol IP address, what we do is the command is standby, and then we want that group number. We're going to use group number 1, and then we're going to set the IP address of this virtual interface. So IP and then space 192.168.1.254. This is about one of the only places where the rule about including the subnet doesn't apply. Usually when you set an IP address or set a network address and you're setting it, you have to put the subnet mask. But if you're connecting to an existing IP address or if you're connecting to an existing network, you don't have to include it. This is about one of the only areas where I know you're setting an IP address, but you don't have to include the subnet mask. It pulls it from the other information on the router. Here we can see that the state change of Gigabit Ethernet 1 is now in group 1 state, and now we are in one of the first states of HSRP, the initialization state. Then we went to standby, and now we're active. Standby, we are listening, the election process happened, and now we are active. Step D, designate the active router for our HSRP group. And once again, the default priority, and we're going to use priorities to do that. The default priority is 100. So if we set our priority to more than 100, then this router will be the active router if all the other defaults are the same. Let's go in and set that priority. Once again, we're dealing with the standby. Start over with, once again, we're dealing with the standby. The command here, we go with standby, and then 1, because that's the group, we have to specify our group, and now we say priority. This is where we can set the priority. Priority range is 0 to 255. We're just going to set it at 150, so it's higher than the default priority on the other devices. And so when election happens, the higher priority becomes the active. Now, I actually typed in standby twice, go back, correct it. What I did is I hit the up arrow, left arrow, I made the changes, and I don't have to arrow back to the right. I can just leave it where it is. I can hit enter, and now the standby changed. And once again, in the Cisco operating system, no news is good news. If you do something wrong, if you type in a command wrong, like right here, it gave me some sort of message, this little caret saying, you have an issue here. Well, if you look up here, I typed in the word standby, and then I typed it a second time. And so it's saying I had an error. If you do something wrong, it will give you some sort of feedback. But when you do something right, like I did right here, it doesn't give you any feedback. And so no news is good news. R1 will now operate as the active router, and traffic from the two LANs will use it as the default gateway. Okay, so if it's desirable that the active router resume that role when it becomes available again, and what we're saying is after the election process, R1, the one we're configuring, is the active router, and then we have the standby. R1 goes down, that default gateway goes down for whatever reason, the standby becomes the active router. If we want the election to happen again when R1 becomes available or that connection gets fixed, we have to say, okay, we're going to preempt that. And we go ahead and say that, and when it's preempted, when that device comes back on, the election process will happen. Do that, it's standby, and then 1 is our group number, and then we just have to say preempt. And it'll start the preemption. Make sure you got your space in there. And no news is good news. What will the HSRP priority of R3 be when it is added to the HSRP group? So what is the priority going to be when it's added? We configured R1 right here. We set the priority as 150. When HSRP is brought onto R3 and is brought into group 1, what's its priority? Well, it's going to be the default priority. It's going to be 100. And so it's going to be 100, which is the default priority. It takes care of step 1. On to step 2. It's desirable. Step 2. Configure HSRP on R3. Configure R3 as a standby router. Configure the R3 interface that is connected to LAN 2. Repeat only steps 1B and 1C. So first we have to figure out what interface is on LAN 2. I'm going to go ahead and minimize our R1 window. And we're looking at R3. Which one is connected to LAN 2? LAN 2 is this network down here. It's this connection going down. Now, what I'm going to do is I'm going to click in this window to make sure this window is active, and then I'm going to mouse over here because what we're looking at is this connection right here. I'm going to mouse over, put my mouse there, and it's going to tell me that this connection is gig 00. And so that's the interface we need to configure on R3. I'm going to go ahead and click on R3, slide it over. I make the window a little bit bigger, nicer formatting. Go ahead, log in with no passwords. So you can type enable. We're in privileged exec mode, global configuration mode with config T. And now let's go into that interface. And once again, that's the gig 00 interface. Interface gig 0/0. It says repeat only steps 1B and 1C from above. Only 1B and 1C. We're going to specify the standby version of 2. We're going to specify what our virtual IP address is. We're not going to set the priority. We're not going to do that. So we're only going to set the standby version. And then we're going to say what the IP address is of that virtual interface. Standby version 2. It's space 2. And then the next thing we want to do is set that virtual IP address. Once again, standby space 1, because it's belonging to group 1. Once again, that group has to match between all of those devices that are part of that group, and that identifies how they group together. And now we're setting the IP address, so we type in IP, and then once again, that virtual IP address is 192.168.1.254. That now brings the gigabit Ethernet 00 into group 1. We're in the initialization status. Let's give it a second. I'm going to scroll down in our instruction window. Very shortly, our HSRP, we went from speaking into standby. And the election process started because we brought a new device online. The priority was lower. This was R3. This was lower. And so that becomes standby. Step 3, we're going to verify our hot standby routing protocol configuration. To verify it, we're going to use the show standby command on R1 and R3. We're going to look at the values here for that. I'm going to go ahead and click on R1. Come down here. Now, we have to do this in privileged exec mode. Currently, we are in interface configuration mode. I'm going to go ahead and type exit. Brings us into global configuration mode. Type exit one more time. Now we are in privileged exec mode. Go ahead and type show space standby, and it'll give us our statistics. Verify the values for the HSRP role. From the output of our statistics, we can see several pieces of information. First, we're going to see what the role is, what the state is. Our role in our HSRP group of devices, we are the active router. We, as in the router 1, is the active router. Then we can see what group we belong to. Right here is the group. We belong to group 1. All the devices, R1 and R3, belong to group 1. That's how we get that grouping of routers. Then we have our virtual IP address here. This is that virtual IP address. It doesn't exist anywhere, but virtually the HSRP protocol is running that. We can also see the status of preemption. Here it says our preemption is enabled. We did that earlier. And then finally, we can see our priority. Our priority is 150. It says it's configured as 150. That's what we have for our priority. Let's go ahead. Let's look at R3. We're going to use the same show standby command. I'm going to open that up. Exit out once to global configuration mode. Exit out twice into privileged exec mode. From here, we can go ahead and do show standby. And we can check that information again. We can see our role. Our role here is this router, R3, is in standby mode. Once again, standby will take over when the active fails. We can see what group we belong to. We belong to group 1. We can see what our virtual IP address is here, 192.168.1.254. That's what we set up. We can see preemption. Preemption is disabled on here. And we can also see our priority. Our priority is 100. It's default as 100. Using the output shown above, answer the following questions. So they want us to use that just in case you have some different numbers in your packet tracer, but they all should be good. Which router is the active router? Well, R3 here is in standby. I'm going to get R1 up here quick too. R1, if we look at the state here, this is active. R1 is our active router. What is the MAC address for the virtual IP address? The MAC address is right here. This is the virtual MAC address. I'm going to go ahead and type that in here. And once again, MAC addresses are 12 hexadecimal numbers. However, the operating system formats it. Cisco does 4 hexadecimal numbers, period, 4 hexadecimal numbers, period, 4 hexadecimal numbers. Windows does 2 hexadecimal numbers, a colon, 2 hexadecimals, so 6 sets of hexadecimal numbers. I'm going to go ahead, since we're dealing with a Cisco switch, I'm going to go ahead and type it in their format. We have 000.0C9F.F001. That's the MAC address for the virtual IP address. What is the IP address and priority of the standby router? Once again, this is the R1 window. This is active, so it's not this one. What we want is the R3 router. R3 router here is the state is in standby, so that's our standby router. That's what they're looking for. Next question, what is the IP address and priority of the standby router? If we look here in our R1 window, this is the active router, and the question is looking for the standby router. What I'm going to do is I'm going to go to R3. This is our standby router. First thing we're looking for is the IP address of it. It's not the virtual IP address because that's the virtual interface. That's what the hot standby routing protocol is using. We want the actual IP address of this interface, the G00 interface. We want that. And if we look here, we don't necessarily see it. The only other IP address is the IP address of the active router. To get this, what we'd have to do is either do like a show run or show IP interface brief or something like that and get the IP address of our G00. Or what we can do is go back to the active router. So I'm going to go back to R1 here. This is our active router. And if we look at the information here we have the IP address of our standby router. So the active router knows the standby router, so that way it can send those hello packets to that standby router. And our IP address of our standby router is, and so the address of the standby router is, and once again, that is 192. Got to type in 192 correctly. .168.1.3, and then they want to know what the priority of the standby router is. The priority is not listed on the active router. We need to go back to the standby router. Here we're on R3. This is our standby router, and then this is where we can see what the priority is. The priority is 100, which is the default. And priority is 100, which is the default. On B, use the show standby brief command on R1 and R3 to view the hot standby routing protocol status summary. Sample output is shown below. Okay, go back to R1 here. I hit enter a couple times just to give me a clean working area. Command we're going to enter is show standby in brief. Gives us some quick information. We have our interface. We have what group it belongs to. We have the priority, what the status of this router is. We have what the IP address of the standby router is, and we have the IP address of the virtual interface. Let's go ahead and enter it in on our standby router. Hit enter a couple times. The command once again is show standby brief. Gotta spell standby correctly. So what I did is I hit the up arrow, left arrow over, fix my spelling error, hit enter, and here is our information about the standby. It's configured on interface 00, part of group 1, has a priority of 100. That's the default priority. This router is in standby state. The active IP address is here. That's the IP address of R1. And then the virtual IP address is 192.168.1.254. The other thing to notice here is underneath standby, it says local. What that's telling us here is the standby router is the local device. It's the device we are on right now. The device we are on is that local, is the standby device. On to question C. Change the default address for PCA, PCC, S1, and S3. Okay, so we're going to change it. First question is what address should we use? What address should we use? Up here, going back to our routers, we're looking at R3. Here's the information. The address we should use is not the physical address. So not the address of the physical active router, not the address of the physical standby, but what we need is that address of the virtual IP address. So that way if one of the physical ends goes down, the other one will take over. This is the address we need, 192.168.1.254. That's the address we should put in there, 192.168.1.254. Okay, so that's the address we're going to use. Let's go ahead and change these. I'm going to minimize our R3 and our 1 window. We got to do PCA. Click on PCA. I'm going to close the command prompt window here. That's on the right side of this blue line that says command prompt. On the right side, there's an X. Go ahead and click on that. Now you can click on the IP configuration application right here. Go ahead and click on that. And we have to change the default gateway from what it's set to, which is the physical address on R1, to the IP address of the virtual interface. which is 192.168.1.254. All we have to do is change that last octet to 254. I click in another field just to make sure it commits it change in packet tracer. And that's all we have to do for PCA. Go ahead and minimize that. PCB. Once again, close the command prompt on the right here. Open up the IP configuration application. And we have to change that IP address of the default gateway. Once again, currently the IP address of the default gateway is 192.168.1.3, which is the IP address, the physical IP address here on R3. That's this one. We have to change it to that virtual IP address, 192.168.1.254. Last octet is all we have to change, 254. And just for good luck in packet tracer, I click in another field to make sure it commits that change. Minimize it. Then we need to go into S1 and S3 and change the default gateway for that. I'm going to go click on S1 and make the window a little bit bigger, right to left. Log in with no passwords. It's easy. Enable config T for global configuration mode. And then we have to change the default gateway. For IP version 4, to change the default gateway, all you do is re-enter that command in to set the IP default gateway. It overwrites it. And so right now we are in global configuration mode. All I have to do is type in IP space default dash gateway and then the new IP address, and that's our virtual IP address of 192.168.1.254. Because we are pointing it to a set address, we don't have to put the subnet mask in. Go ahead, hit enter. All you have to do, I exit out. And that takes care of switch 1. Go ahead, minimize it. Now we go to switch 3, do the same thing. Make the window a little bit bigger, right to left. Log in with no passwords. Enable config T. Set the default gateway. Command once again is IP space default dash gateway. And then the IP address, that IP address of the virtual interface, 192.168.1.254. That sets that. I exit out. We set that all. Verify the new settings. Verify the new settings. Issue a ping from both PCA and PCC to the web server. Are the pings successful? PCA. I'm going to close the IP configuration. Blue line, right side, click on the X, open up my command prompt, and now we're going to ping the web server. The web server IP address, once again, is 209.165.200.226. The ping command completes. We sent out 4 echo requests. We got in 4 echo replies. Successful PCA to the web server. Let's try this on PCB. Close the IP configuration. Blue line, right side, click on the X, open up our command prompt, type in ping space, and then the IP address of our web server, 209.165.200.226. Sends out the ping. We send out 4 echo requests. We get in 4 echo replies, 0% lost, 4 sent, 4 received. Life is good. It works successfully. We were able to go through that virtual IP address for our default gateway. Now, the question we have to fill out is, were the pings successful? Yes, they are. That's the end of part 2. On to part 3. We're going to observe how hot standby routing protocol operation works. Step 1, make the active router become unavailable. Open up the command prompt on PCB and enter in the command traceroute 209.165.200.206. We're going to do a traceroute to our server. Open up PCB. We got our command prompt here. We're going to do a traceroute, TRACERT, and then the IP address of the web server, 209.165.200.226. Here we have the results from the traceroute. We go through our 4 devices. We go through the physical host. Even though it's set as the virtual host, it routes through that physical address. And that's where the hot standby routing protocol takes care of where the traffic goes between the active and the standby router. And then we go through the router, the internet, and finally the web server. Does the path differ from the path used before HSRP was configured? Actually, it does. This is PCB. PCB ran through R3. Now we're going through R1 because this is the active router. The path is going through there. It's the active router. The path is different. So it is going through R1, which is different than what it was. How is the trace route different? Sorry, does the path differ from the path used before? Yes, it does. Now goes through R1 as the first hop. Okay, let's break the link to R1. Select the delete tool and delete the cable from R1 to R3. Immediately return to PCB, execute the trace route command. Because we already entered it in, to quickly enter it, all you have to do is up arrow. And I'm reading these steps because I know it happens fairly quickly. Observe the output until the command completes execution. You may need to repeat the trace route to see the full path. Okay, here we go. We are going to delete the connection from R1 to S1. We are going to delete this connection right here. This is currently the active router in a hot standby routing protocol. We're going to delete this connection and HSRP should take over, and now traffic will get routed through this other connection. Okay, I got my PCB window here. Up arrow is ready to go. I didn't hit enter yet. Click on the deletion tool right here in the upper left corner. On the menu bar, it's sort of a box with a triangle pointing to the left with an X. I'm going to go ahead and click on it. It says, do you want to delete the selected item? I don't know what's selected. Actually, R1 selected. No, I don't want to delete that. I'm going to cancel. I'm going to click in this white area so nothing is selected. You see how when I click on R1, it's a lighter color. What I'm going to do is I'm going to click off of it so nothing's a lighter color. I'm going to come up here now, click on the delete tool. My icon changes to this black crosshair. This is the connection we want to delete. I'm going to go ahead, click on it. Click on it. I had to find the right spot. And now I'm going to repeat that trace route command. Oh, it's broke. It's thinking about it. Now all of a sudden we see, okay, it took over. Now we have a different IP address. We're still having a little bit of a failure, maybe. Request timed out. Okay, so we're waiting for this to work. Currently, right now, we went from PCA all the way to switch 1, switch 2, through switch 1 through switch 3. We were able to ping this IP address. I'm going to change my tool from the deletion tool to the select tool. That's this dotted rectangle here. Now my cursor is the normal point. And we got some timeouts. We got that, but we're seeing that. Let's go ahead and repeat that command. Just up arrow again, enter it. And now we can see the results of our full trace route. Here's the trace route we just ran. Notice our first hop, 192.168.1.3. Here's the trace route we ran before we deleted it. Our first hop was 192.168.1.1. First trace route went through R1. Now, because we disconnected it, HSRP said, you're no longer the active router. We're going to make R3 the active router. Now the traffic goes through R3, which is the IP address here of 192.168.1.3. How is the trace route different? The first hop changed to R3. Okay, so first trace RT, the first hop was R1. Second trace RT, the first hop was R3. And so the first hop changes. Everything else was the same. After R3, we go up to R2, then the internet, then our web server. Those were all the same. Right here and here, that was all the same. The difference here is that first hop going between R1. Break the connection. Now it's R3. Step 3, restore the link to R1. Now, we broke it. Let's go back, reconnect it. Because we have preempt set on R1, it should force the reelection process, and it should go back. The active router should go back to R1. Let's reconnect R1 to S1 with a copper straight through cable. Click on a copper cable, click on R1, gig Ethernet 1, come down here to S1, click on the other gigabit, is way down at the bottom of the list. We have to wait 30 seconds, or if we come right down here, click on the two triangles pointing to the right, we can fast forward, and the switch is done with its negotiation. Execute the traceroute again from PCB to the web server. May need to repeat the traceroute to see the full path. Open up our PCB. Let's repeat that traceroute. All I'm doing is hitting up arrow, hit enter. And we're thinking about it. First one timed out. HSRP election was still running. Once again, we forced that election because we have preempt set up on R1. But now we are back going through the IP address here of R1. When this connection was restored, we have preemption set, reforcing the election. R1 had the higher priority. R1 has a priority of 150. R3 has the default priority of 100. Priority of 151 wins it for R1, becomes the active. Now traffic travels through R1. What is the path used to reach the web server? Well, we are going through R1. So the path is from PCA to R1 to R2, internet and web server. So the path to use the web server, R1, R2, the internet, and then web server. If the preempt command was not configured for HSRP group on R1, would the results have been the same? Would the results be what we just got when we last ran this traceroute command? Well, remember, preempt says we're going to force the election. But by default, once you're the active router, you are the active router until you cannot function as the active router, so that connection goes down or the router goes down, or somebody with preemption set comes online in your group. And so the answer here is no, it wouldn't be the same. R1 would not become the gateway again. The path through R3 would continue to be used. Takes us to the end of the lab. That was Packet Tracer Lab 9.3.3 Hot Standby Router Protocol Configuration Guide. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.